Now, let's go to see the architectures of network slicing. The basic idea of network slicing is to slice the original network architecture. Here is the lower part, and slice this lower part in multiple logical and independent networks. It's the middle part in this figure. And these independent networks are configured to effectively meet different service requirements. So these service requirements are from the top part of the service instance. To realize such concept, several techniques are employed. The first technique is network function. So network function express elementary network functionalities that are used as built blocks to create every network slice. The second technique we need for network slicing is virtualization. So virtualization provides an abstract representation of the physical resources under a unified and homogeneous schema. In addition, it enables a scalable slice deployment relying on network function virtualization that allows the decoupling of each network function instance from the network hardware it runs on. So after having the network function and the virtualized network resource, we have to think about how to make them to be connected. In this case, we need the third technique, orchestration. So orchestration is the process that coordinates all the different network components that are involved in the life cycle of each network slice. In this context, software-defined network (SDN) is employed to enable a dynamic and flexible slice configuration. These concepts together enable the design of the main components of the network slicing architecture. This is as an instantial of the above concepts. The corresponding architecture for the management of network slicing is illustrated in Figure 10 with the following main components. Virtualized infrastructure platform, we call it VIP. Network slice instance, NSI, and management and orchestrator, we call it MANO. So first, the virtualized infrastructure platform. The platform provides virtual resources such as virtual computing, virtual storage, and virtual network to assign to one or more slices. Virtualization is performed through a virtual infrastructure manager. Network slice instance. It's a collection of resources from the virtualized infrastructure platform. They are organized to form a network slice. The different functionalities are allocated by the network function virtualization manager based on the directive by the NFV orchestrator. So the last part, MANO. This main component contains submodules. They are a group of dedicated modules like Network Infrastructure Manager, VIM, and also the virtual network function management, network function virtualization orchestrator, and network function virtualized manager respectively. The SDN orchestration, software-defined network orchestrator, and the net slicing management function. Each virtual infrastructure manager includes one or more SDN controllers to enable virtualization. Here we see the relations between aforementioned techniques and components. So the virtualization is performed by a virtualized infrastructure platform, and then the network function stays in network slice instance. In the end, the task of orchestration is done by the management and orchestration mono component. Next, I'm going to introduce 3 typical architectures to implement the overall architecture. Each of them provides advantages and disadvantages. They are briefly reviewed in the next slides. So the first one, we call it single owner, single controller. So obvious, it's a network slicing architecture with a single controller or orchestrator. The SDN environment provides an abstraction of the network resources through the northbound interface of the SDN controller. The management and orchestration functionalities are subsequently implemented on top of the SDN controller by exploiting the northbound interface. In this case, the SDN controller operates as the SDN orchestrator. It's also the main part of the mono in the general architectures. So this solution is limited. It's for limited regions of the network, especially in the case of a single owner infrastructure, because the SDN controller completely controls all the different slices, but it may represent a bottleneck in terms of performance and the reliability. The presence of the single controller limits the programmability of the networking infrastructure in case multiple tenants desire deploying network services. The second one is single owner multiple tenants, because supporting multiple virtual networks is now becoming common in many settings, from data centers to service provider networks. So in this framework, an alternative technology to implement network slicing is the usage of SDN proxy, typically controlled by the owner of the physical network infrastructure. In this case, the SDN proxy provides an abstraction of the network forwarding path that allows the SDN proxy to slice the network. The proxy employs the SDN protocol to define a hardware abstraction layer that logically sits between controller and forwarding path on a network device in order to enforce the rules and agreements defining the network slice and to maintain isolations. The advantage of this scenario is that it enables multiple virtual tenants to deploy their all controller or SDN orchestrators on the shared infrastructure, and meantime maintaining the isolation between different slice instances. An example of this solution is FlowVisor. Actually, FlowVisor is implemented as an OpenFlow proxy that transports messages between OpenFlow enabled switches and the OpenFlow controller. FlowVisor defines a slice as a set of flows running on a topology of switches. It sits between each OpenFlow controller and the switches to make sure that a guest controller can only observe and control the switches it is supposed to. So this figure is an example of OpenFlow message exchanging in an architecture using FlowVisor. So FlowVisor intercepts the OpenFlow message from guest controller Bob, and then using the user's slice policy, it's step 2, using the user's slice policy and transparently reveals the message and to control only a slice of network. So the job of FlowVisor here, it's mainly like the slice policy translation, validation, and then forwarding. So the messages from the switches are forwarded only to the guests if they match the corresponding slice policy. So all the check and translations are done by the FlowVisor. Here, the job of the FlowVisor is an SDN proxy. The third one is multiple owners or multiple tenants, because virtualization is essential to allow multiple tenants to specify how they desire their resources to be connected. It is expected to be independent from the service or infrastructure providers. The previous mentioned architectures are mainly focused on generating slices of the underlying network infrastructure by dividing or isolating the linked resources. But the generated slots allow one or more controllers to operate only. The additional requirements for enabling complete freedom for the tenants are needed, like how to define their desired network topology and so on. It implies the need to introduce an advanced virtualization layer in the virtualized infrastructure platform. And this virtualized, or we call it abstraction layer, should be on top of the physical network, but still under the virtualized resource. And then such kind of virtualization layer can be organized, managed, or orchestrated by a new introduced technology or component. We call it OpenWortX. OpenWortX represents an example of a network virtualization platform. It allows tenants to specify their desired topology and addressing Meantime, it enables the infrastructure owners to retain control of its own virtual SDN network. It defines a flexible virtualization environment to provide to tenants controllers or network operating system. The SDN orchestrator have more degree of freedom in defining topology and configuring on their slices. The virtualization and abstraction layer sits in between the physical infrastructure resource and the virtual network controllers. It allows to create isolated virtual networks with the topology specified by tenants. Also, it allows to use any controller or network operating system. Users can use the whole address space and change the virtual network and runtime. Slices also can be automatically recovered from physical failure. So one of the typical examples is the open vertex, which we mentioned in the last slide.